Okay, hopefully this is working. I've upgraded to 1.7.10 and I am now facing the more interesting stuff. That can go. Got enough food to live. Probably don't need that. Don't need creeper food, fuel, whatever. I'll keep those. And I might run in a new lump of wood just in case. That should give me. I've only got. Oh no, I've got plenty of torches. Brilliant. Okay, that should keep me going for a while with enough space to invest. Anyhow, 1.7.10 is the version that used to run the old bucket server and all that kind of stuff. So it's been a lot of fun tweaking with it, and I need a new pick. Forgot about that. All right, back up. So yeah, 1.7.10, favoured by bucket servers and all that sort of stuff. Although a friend of mine's one of the admins on Sprigget, which is, I suppose, similar to Bucket. Although, having said that, they'll probably abuse me for such things. And dun, 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 blah, blah, blah. Alright, and collect. And those two can just, not that one. And that gives me enough to keep going for probably a little while, one would hope. Probably don't need that. So yeah, I mean, there's plenty of options out there for setting up your own Minecraft server, and maybe I should do that at some point. And certainly one that I will not be playing online, just as an example of how to set up a Minecraft server. Because, you know, spending all your spare time playing Minecraft seems like a very foolish idea. Scoff, 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 he says as he plays Minecraft. So, yeah, new area. Oh, underground area. Ooh, right. This is where I was exploring when I had the spate of, let's not do this foolish thing. And that is now empty, so that can be sealed up. Yeah, so I need to talk about some interesting new topic with everybody now. And that topic tonight will be artificial intelligence. What the hell is it anyway? So, simple definitions. Let's start with, ouch. Yeah, fall into my death. That's a lot of fun. Oh, another tunnel. I might just make a hole. And I spotted more iron. That's annoying, so let's just get rid of that. And while it drains, I'll go mine this stuff out. Yeah, so artificial intelligence, I mean, how do you describe it? There's a lot of underlying techniques and stuff used in the development of this software, and it really is just software, it's nothing fancy. Well, I suppose it's amazingly fancy for its simple results. The idea itself at the center of AI is excessively simple. Basically, the algorithm is complex. It's simply complex, let's put it that way. And I know it sounds like an oxymoron, probably because it is. You heard it here first. But basically, just like the human brain, and that's all it's copying, is emulating the human brain. And a lot of programming concepts are replications of real world things. This looks interesting. And that sound not good. Okay, that sounds like badness. Okay, this is fine. Fine? I am fine. How are you? Yeah, so this is going to be challenging for myself to find a good definition for AI. But let's start with the basic thing. It copies a neuron, how a chunk of the human brain works. So, as the basis of it, what you have is, don't look at them, they'll get you. They get you every time. No, it's coming this way. Ah! Ah! But I want to go that way, I want to get the goodies. It's so unfair. Oh, I didn't even realise that was up there. Hello, zombie. Need more light. Yeah. So, gee, before I got distracted by zombie, that's not a phrase you hear every day. So the first thing is there are basically the setup has a feedback loop, or better starting point. Basically, it has an input and an output. That's it. It has a value to define how much is required to trigger it. And it'd be so much easier if I had a diagram, which is the challenge here. Ooh, gold across some lava. And more upwards deathness. And getting a new pick. I'm doing a really crap job of explaining this thing. Okay, so it has one or more inputs that can be channeled into it. Each input has an amount of influence between 0 and 1, which is basically a percentage marker of how much it will be affected by said thing. So it also has a trigger threshold, so that as an individual neuron is triggered, it will then decide whether or not to send out a signal further. So that, in a sense, gives you a bit of an overview of how the core structure of an AI works. It's not particularly exciting, but it gives you... That should be enough to get up there. And if there's deadlies, then I'm running away, because I'm so brave, so Robin. All right, that's just fallen out of here. So that's the basic structure. This goes on forever. I don't want to go this way. It's leading me away from the goodies. So I'm really tempted just to seal that off and forget about it forever. I'm bound to find, given how complex this is, I'm bound to find it another way. All right, that'll do. So given what makes AI special is that the fact that we now have the processing power to throw together hundreds, if not thousands, of these artificial neurons. And yeah, you kind of got the one guy who taught this as a tutor at uni, so tough guys. So this set of artificial neurons will then trigger a whole bunch of output states. Now, back when I was doing it at uni, it could manage 1 or 2 layers of neurons as a general process, and we didn't have the processing power to go further without anything major or special going on. So that kind of restricted what was capable at the time. But now that we've got basically large-scale computing systems doing pretty much massive amounts of work, or capable of doing huge processing things, we're able to actually then do these massive scales of processing. Okay, skelly bones in the distance and a zombie. Whoops. Bugger you. They did have to be quiet. I'm going to have to secure the area first, I think. Okay. This sounds devastatingly interesting. And not fun at all. So step 1. Lock myself in here. Step 2, have fun. So, so by upscaling these neurons, you're able to create more and more complex structures. And stuff like, what are the examples? Hurry up and die, you little gribbly. I better eat something so I can regenerate. So as a result, by upscaling these huge data structures and throwing, before I get to throwing massive amounts of data at them to educate them, basically what happens is that you get a neuron structure, And these structures need to be refined and improved. And what happens is that you have a feedback loop. So when a set of neurons gets to a good answer, one that you want out of your training set, you give it some positive reinforcement, which means, hey, this was a good answer and you should do more things like this. And AI programming in this sort of sense with neural networks is actually really funky for training detection and, well, not detection, but training classification. So grouping things into logical bits, which of course is one of the things that people tend to be very good at. That's now done, and I need to seal this area off. So that one, that one, that one. That's done, and just work a torch up here. So, okay, nothing happening here. I do want to go that way in just a second, but we're just going to grab a bit or two here. Yeah, so where was I? Training networks, yeah. So what you do to train the said network is throw massive amounts of data at it. And when I say massive amounts, I'm meaning, 100,000 entries in your little data set. And so this was the training that was happening early on with AIs back in the late 90s. Since then, it's sort of grown and evolved into different sorts of things. So this was using a training set that you knew what would be in it, and of course you could then, I suppose, govern what the AI would learn. But it still only had direct application in terms of one narrow set of things it was good at. The interesting stuff would come along a little later. So, excellent dead end. So with a large training set, you could train it in certain ways, and this was controlled AI. Now, the next sort of, I suppose, technique was to take this controlled idea and basically just give it a data set and see what it'll find. But the thing is, again, we're talking over 1 million discrete pieces of data, or not pieces of data, data points. No, not even data points. It's not quite data sets, but it's basically, having a physical location of the Earth. And so as an example of this data set, it would be, instead of being a single point of data like your position on the Earth, it would be your position of the Earth plus other relevant data related to what you were doing and at the time and that sort of stuff. And this is pretty much where Google's at. Okay, and then I need something for the gold. Yeah, so yeah. Throw a torch behind there just in case, because like zombies. I'm zombiest, I know. And I'll just seal off that water for the time being. Yeah, so throwing this exceptionally large data set at things. Oh, this is a horrible area. Yes, very horrible. Good, that's a dead end. Would get interesting results. And some of the good examples, one of the ones you may have encountered was, not OK Goes, that's a band, was AlphaGo, which uses an interesting technique to train it in how to win at the game of Go. But this, oh shit. Well, that stopped that. At least it didn't cop the explosion. And it opened up more stuff. Wonderful. Do I really want to go down there? Probably. But the actual technique was originally developed with a different program which was around backgammon actually. Yes, you burned to death, thank you. Where basically it was adversarial AI. The two would basically duke it out to get to the best solution, and they were able to play, instead of using a restricted data set, they were able to basically do hundreds of thousands of games against each other to arrive at the better solutions. Now, the interesting thing is that when this was happening, what they did is they discovered a new way to play backgammon. It was just a single move right at the start that would change the outcome in a dramatic way. So the end result was that it created a small efficiency hurry up and die in the actual playing of that game. And it was just coming up with a certain dice combination and that sort of stuff, and it was actually really worthwhile for them to the competitive backgammon players to actually follow this idea. So it was of a huge amount of benefit to them to do that level of analysis on the game of backgammon. So I don't like this. This is going to go down into lava, I suspect. Bye-bye, diamond. That sucks. I should have actually dealt with that. Oh well. So in terms of this sort of technique, what they did was identified a better way of playing the game. And of course that leads to huge benefits across the board in this sort of case. Ouch, cop that in the back. I can't kill it with a torch though. How did he get one in the head when he was dodging? Oh, that's harsh. Harsh, I say. So that technique was then taken on by the AlphaGo team, and AlphaGo, I think it was one, basically used this adversarial used a training technique to look at all the history of the games of that sort of stuff, of the game of Go, and basically tried to play a better game based on that. AlphaGo Zero, on the other hand, played against AlphaGo 1 and then itself to achieve a far superior thing in terms of what it was capable of. So this is where AI gets really intelligent and kind of scary, because we don't always control the outcome, because we don't control what goes in. It's kind of like working with children, really, or working with people. You don't even know exactly how they're going to react. But here I am making analogies of AIs and humans being the same thing when we know that they're not, because we've been told they're not. Oh God, it goes on forever this way too. Over the hedge, what a wonderful thing. So in terms of artificial intelligence, that sort of covers the techniques, the branch of AI that focuses on using neural networks to elicit responses of what you want. And it requires large data sets, but a company like Google, they won't even consider a problem that is too small for them. So one of the examples I gave was, or have given previously, not here but elsewhere, is around horse races. You have a track, you have no timekeeping device, and you have 5 lanes in that track, and all you know is the order that the horses come in. And I'm probably lost at this point. This is wonderful. I'm going to take hours to find my way home. This is why I seal up all the side passages, because you know what? I'd like to be able to get to the surface at some point. Because I have stuff that needs stuffing. Oh, hello, Bat. And I've kind of lost the plot again. Isn't this wonderful? This is for me. I should seal up the ways I am not going. Maybe I'm going around in circles. I'm stuck here forever. I should start using technique number 2 and put signs up and saying, this way home. Yes, that's the way out. So yeah, there's a lot of techniques used to develop artificial responses. And I'll cover some of those later, I think, because I don't really need to do everything at once. Whoops, wrong spot. Oh, you're kidding me. Bloody hell. Do I have to? There, done. Alright, dump the coal, the bones, that. Probably even that, those, that. And I'm down to about half picks. Oh, not too bad anyway. Take that to the surface. Those, probably one of those. Leave the rest here. That looks good enough. Oh, shears. And the ender pearl. So yeah, I mean AI is a huge massive area and there's a lot of stuff going on in it. As a field it's always evolving and changing. There's new stuff coming out fairly regularly. Yeah, so I'm going to call it quits here for now and I'll talk to you next time. Oh, one thing I will be doing is I'll probably be dropping this back to 3 times a week because that way I can do other stuff. So anyhow, see ya.